Heart attacks among younger demographics have been steadily climbing for years. For decades, the medical consensus has heavily targeted one specific culprit: high cholesterol. The primary strategy was to lower bad cholesterol to prevent arteries from clogging. But a recent analysis revealed a massive anomaly. This data visualization shows the result of a study that isolated the arterial blockages from 101 heart disease patients. Researchers found that in 78% of these individuals, the blockages contained live bacteria that are entirely native to the human mouth. Finding oral bacteria deep inside cardiovascular blockages means that bad diets, high stress, and cholesterol are not the sole causes of heart failure. Clearly, there is another hidden mechanism at work. In 2005, the Mayo Clinic investigated thousands of heart surgeries to understand why certain patients experience severe, sometimes fatal, complications during their operations. This statistical comparison illustrates the pattern they discovered. Roughly 1 in 10 heart patients who suffered massive complications or died during surgery had undergone a dental extraction shortly before their operation. Biologically, this presents a contradiction. If oral bacteria travel from the mouth down the throat, they land in the stomach. The highly concentrated hydrochloric acid in the stomach destroys almost all of them before they can infiltrate the rest of the body. The bacteria surviving in these heart patients are not navigating the digestive system. They are bypassing the stomach entirely, utilizing a direct biological backdoor that connects the jaw straight into the cardiovascular system. The human mouth naturally hosts hundreds of bacterial species, kept in a delicate balance by saliva. But when you introduce simple carbohydrates, like sugar, that ecosystem is violently disrupted, allowing specific harmful strains to multiply out of control. One of the most aggressive strains is Streptococcus mutans. It consumes those simple sugars through fermentation. The natural byproduct of that fermentation process is highly concentrated lactic acid. Your teeth are shielded by an outer layer of hydroxyapatite crystals and collagen. The lactic acid physically melts away this protective barrier, a process we commonly call tooth decay. Once the acid burns through the hard exterior, it reaches the central pulp of the tooth. This area is packed with highly sensitive nerves and, crucially, direct lines to the body's circulatory system. The bacteria now have an open gate to your bloodstream. If a dentist treats that severe decay by extracting the tooth, the physical trauma of ripping it out of the jaw instantly forces millions of these swarming bacteria straight into those newly exposed ruptured blood vessels. By attempting to remove the localized infection, the extraction inadvertently launches a massive bacterial payload directly into the body's high-speed transit system. Down in the cardiovascular system, the heart relies on a microscopic maintenance crew to repair tissue damage and keep the organ functioning smoothly under stress. This diagram shows human heat shock proteins in action. Whenever the body experiences stress, it deploys these specialized proteins to patch up damaged cellular walls and keep the heart tissue stable. When the infiltrating mouth bacteria arrive via the bloodstream, they realize they are in hostile territory. To defend themselves, they release a chemical called HSP60, which floods into the same area where the human repair proteins are working. The fatal biological flaw is that the bacterial HSP60 is 60% identical to human heat shock proteins. When the body's immune system detects the bacterial invasion, it deploys antibodies to eliminate the threat. But the antibodies cannot tell the two proteins apart. They indiscriminately attack and destroy both the bacterial defenses and the human repair crew. The resulting blockages and tissue death in the heart are not directly caused by the bacteria forming a physical wall. The body's own immune system is tricked into assassinating the precise proteins responsible for keeping the heart alive. Preventing this specific type of sudden heart failure requires neutralizing the oral microbiome long before it can melt through the enamel and breach the blood barrier. First, consuming sugars only alongside full meals utilizes the body's natural defenses. The heavy saliva production triggered by a large meal physically washes away and neutralizes the incoming lactic acid before it can settle on the teeth. Replacing simple sugars with complex carbohydrates like oats or broccoli removes the bacteria's fuel source. These foods resist bacterial fermentation, and the heavy chewing required to eat them stimulates even more protective saliva. Highly acidic soft drinks directly lower the mouth's pH far below normal baseline levels. This bypasses the bacteria's need to ferment sugars entirely, artificially creating the exact corrosive environment they need to rapidly multiply. Chewing gum sweetened with xylitol acts as a physical antibacterial trap. It provides the bacteria with a substance they eagerly consume but biologically cannot process, effectively starving the colonies to death while simultaneously cleaning the teeth. If the enamel shield does sustain damage, a 5% fluoride treatment acts as a localized remineralization agent. As this diagram shows, the fluoride molecules physically bind to the eroded gaps, actively rebuilding the protective outer wall. Proper daily dental hygiene is the absolute first line of defense for a healthy cardiovascular system. Keeping the mouth balanced prevents the immune system from destroying the heart later on. Understanding the exact mechanics of how your biology functions gives you the precise instructions needed to protect your vital organs and extend your life.